Okay, so thanks everyone for coming along today. We hope you're having a great time at PyCon. We have 30 minutes to talk a bit about how we run tests at Demonware. We use containers quite heavily at Demonware. We have done for about 3 years now. So we're going to go through the process and some of the pitfalls that we went through in the past 3 years, and hopefully this will help you kind of run tests in containers and to improve your deployment pipelines. So this is just a quote we picked randomly from the internet, but it's very true. Everybody wants quality, but it does take an investment. It's not something that just happens overnight. To define a really quality process can take years, and it takes a commitment from lots of different teams. I'm in the build engineering team at Demonware. We work very closely with development teams to make sure that their builds are stable and that they can run their tests in a reasonable time, and that we can deploy the code through to production without any sort of major problems.
So Demonware are wholly owned subsidiary of Activision, and we provide the plumbing, you could say, to let video games communicate with each other, let players match into games against each other in some of the biggest video game franchises. So we released Call of Duty Infinite Warfare yesterday, or on Friday, and Skylanders Imaginators last month. So these are our services and our clients. And then just a bit about us.
Okay, so I've been at Demonware for 4 years now. We never had a build engineering team until 2012. Developers were kind of trusted to push code through into production themselves. It didn't work so well. It was efficient because developers could just push directly from their desktop into production, but stability-wise, it wasn't great. We had developers trampling over each other to try and get fixes into production. So build engineering came in, and we tried to put a bit of process around how we get code from the commit all the way through into production.
And when I came to Demonware, I was coming from a Django project to another Django project, but I was coming from a completely untested Django project to a Django project with like thousands of unit tests and Selenium tests and stuff like that. So it was a big change for me coming from a startup to a bigger company. So I had to kind of smarten up quick and learn to love the build engineering team, who were very helpful and helped me get through the testing process.
Okay, so this is just a very rough agenda of what we're going to be talking about for the next 20 minutes. We're going to start with continuous delivery first. One of the reasons we chose containers was because it gave us the tools that we needed, in particular Docker. It allowed us to push code through the pipeline nice in a stable, portable way. So we're going to talk about continuous delivery, and then we'll lead on to some of the tools that we used for building and testing our code. Okay, so this probably looks very familiar to a lot of people in the room. It's all about getting your code out to the customers as fast as possible. At Demonware in 2012, it was very ad hoc, it was manual, there's lots of breakages every day. We had developers using Snowflake build agents. So Snowflakes are basically agents that have been set up manually. Everybody had root access, they broke every day. People were just doing really crazy shit on these build agents. So we wanted to move away from that. We wanted a continuous delivery pipeline that was more stable and that was using immutable infrastructure. We wanted to be able to build environments within minutes. We wanted to move away from the whole manual process of getting code from A to B. And this is what we were moving towards.
So we wanted to get everything out as fast as possible to our customers and to the both external and internal customers, so that we could just make things quicker to turn around when there was an issue or when we were pushing a new feature, and crucially to allow people to do the acceptance testing much faster than the previous process would let us do. So when you set something up like this where you're pushing code much faster, you suddenly realize that you can't permit quality to dip anymore, because something goes wrong and it's out in production 15 minutes later. That's much more problematic than if you've got a much longer build pipeline where things might be manually tested. So in the best case scenario, when you have this continuous delivery sans quality, you end up with the pipeline itself exploding and sort of just dumping your bad code somewhere in the middle, and so it doesn't reach production. But obviously in the worst case, the bad code kind of just like bumps through every kink in the pipeline and just squirts out onto production as it's bad. It's a bad time. So we wanted to make sure that the continuous delivery pipeline was quality as well. And part of that is like trying to increase the speed of it. We were getting through the build and deploy stages very quickly, but the testing stage, there were thousands of unit tests and some of them were very, very slow. So we were looking at hours for these test suites to complete. So we just needed to like focus in on that and try and get some more speed there to make the total turnaround time faster. So we kind of took a two-pronged approach. We had the developers statically splitting tests across containers. So we'd run like one set of tests in one container, another set of tests in another container, up to however much we wanted. And then we could measure the individual execution time of each test to kind of try and make the split more intelligent, but it was still static. And then quality metrics like static analysis, like Flake8 or whatever, and also test coverage reports.
Okay, so continuous delivery, whenever it is set up, it is quite a complex process to get it right. It's even more complex whenever all your build agents, all your test environments are all completely different and are all being managed by different teams and managed to a different standard. What we wanted to do is to provide a test infrastructure that could be built from code. It was fast to build out a new container, run your tests, move your code from A to B. We also wanted to eliminate dependency hell. In the build engineering team, the first few weeks I was there, every single day we had teams come to us asking us to install certain versions of Python libraries and certain tools in the build agents. And most of our day was just spent like installing stuff and tweaking configuration. Whenever we moved to containers, that just got wiped out overnight. We gave the teams the control to install whatever dependencies they wanted. If a team needed a really specific version of a Python library, they get to control that and they build the image that they need. If the image breaks, it's their responsibility. So this basically got rid of dependency hell overnight. Okay, so pets and cattle it's very commonly talked about. In Demonware, we've had one extreme where everybody had root access on our build agents and test environments, and every day there were breakages. This is no way to you can't really have continuous delivery if you have that sort of environment. So we wanted to move towards cattle, and we chose Docker containers as our way to run builds and tests. There's a number of characteristics of containers that work really well for tests. It's lightning fast. If you want to start up a container to run a test, it takes like less than a second. It's all built from code. Teams are much more likely to share containers than they are VMs because you can move them around your infrastructure really quickly. We have an internal Docker registry, so Team A can build a container for their service, push it to the registry, and then teams B, C, and D can pull the container down and use that for their own tests. So that's one of the reasons we wanted to move towards this sort of infrastructure as code for our cattle. And this is what it used to look like 2012. We just had CentOS 6 installed on a bunch of servers. Everybody had access. It was a real mess. It was like the Hunger Games. The developers just were killing each other to try and get their builds green. So we moved into present day. We went through the VM stage, which a lot of companies commonly would move to from bare metal. VMs they worked okay for a year. They were quite slow. We tried using snapshots to speed things up. It wasn't that reliable. And then we moved to Docker containers in 2014. We haven't really looked back since. We use Docker containers for running our builds, our tests. We deploy tools around Demonware in Docker containers. It should take no longer than 1 or 2 minutes to run a tool that you've got no understanding of at all. We had a problem in Demonware where we had lots of tools that weren't very well documented, and it could take you 2 or 3 days just to get the tool actually working because there's a lot of complexity in there that it wasn't documented very well. So now you just get a one-liner from the team, and you can start up a service or a tool, and you're ready to go within a few minutes. If it takes you more than a few minutes, then something's really broken.
So there were 4 stages of evolution when we wanted to move to containers. We started with fat containers. We did containers wrapped in Bash. Then we moved to containers defined in YAML, and then containers as a service, which is what we're talking about today. So a fat container is basically just where you kind of tar up a VM and you just squash it into a thing that Docker can understand, and you end up with this really, really large Docker image which has all the bits and pieces that you want in it, but it's outsized, and it's basically trying to use the wrong metaphor. You end up losing the benefits of Docker a lot because your image is too big, so it takes ages to pull, and then it's got too many services, so you have to check each of them individually, etc. So then we moved to containers wrapped in Bash, where we did have services split out by container, but we had to actually hook them up, and that's pretty non-trivial once you get to like 3 or 4 containers that are all kind of spinning up some kind of service. So we had this Bash script, which would be like, okay, keep waiting until service A is available. Service A is good, all right, sweet. Let's deploy service B. Keep waiting until service B is available. This kind of thing. And this was fine at first, but it grew some warts over time, and ultimately became duplicated too much to be maintainable.
Okay, so we probably should have asked at the start of the presentation, how many people are using Docker on a day-to-day basis? Okay, so a fair few of you know what we're talking about. For everybody else, we apologize if we're talking about Docker and you've got no idea what we mean. Once you start using Docker, very quickly you start to scale out the amount of containers that you're using. It becomes quite complex to manage this locally if you want to do your development or testing. But if you want to run your service across an entire cluster, it becomes very difficult to do that using Bash or using any other sort of like hack-together scripts, which we were doing. So in 2015, Docker released a tool called Compose, and it allows you to define multiple containers and link them all together. Okay, so you can just give somebody a Compose file, they can run one command, and you'll have a full set of containers all linked together, and you can use that to test against, or you can use it to develop against. It's just a really clean way of moving these complex services around the company. Okay, the only problem we had with Compose really was that it just runs on a single host. We wanted to scale our tests out to be cluster aware, and running on one host, we kind of hit a bottleneck with resources. This is going to change very soon though. Okay, so these are some of the limitations. We had the development teams optimizing their tests. We had the build engineering team optimizing the environments, but we really wanted to kind of combine that together and be able to scale it out. You can see some of the common problems we have here. Everything's fixed resources, fixed number of tests, fixed number of containers. We wanted that to be more flexible. If you're in a real rush to get a release out and you have like lots of resources available, you should be able to just hit a button, and instead of your test taking an hour, they should happen in 5 minutes. That's what we're kind of aiming towards. Okay, so this is where we are right now. Docker released 2 really cool features back in August. One is swarm mode and the other is services. So swarm mode basically allows you to connect a bunch of Docker engines together. So if you have a bunch of resources in one team that's being underutilized, they can donate their hardware into another team just by joining their hardware to a swarm. Okay, so it can be like a temporary measure to help another team out, give them extra resources. Or if you would just want to give individual test clusters to each team, it's very easy to do. It's just two lines of commands, really. And the other thing is services. So instead of having a single container that runs your service, you have like multiple containers that all basically provide the service if one container goes down. Docker Swarm is smart enough to relocate your service to another node that's healthy. Okay. And this is what it looks like. We did an experiment a couple of weeks ago called Swarm 3K, where we basically we worked with the Docker community to donate 3,000 nodes into the same Docker Swarm. And you can donate them in as workers or managers. So workers basically just run your containers. They don't do anything else. The managers can control what services are running, and they can run global services across the entire swarm. So if you wanted to have, for example, a Redis container, you could have one Redis container, and every node has access to it on the overlay network, which is really powerful. It's great for testing as well. Instead of every team spinning up their own DB, Redis, RabbitMQ, you can provide one centrally inside your swarm, and every team can hit the same one. Okay. There's loads of really good documentation online if people want to read up on Swarm. It's really quite a cool feature.
So to do the actual testing as a service, we wanted to make the containers cleanly scalable, like dynamically, where we could end up with, okay, I have this many unit tests, but I have half an hour to do this in, and I really don't have time to wait for my normal unit test length. So I'm going to spend the money and have like much more much more parallel execution, and that's what Swarm services will let us do that. But to get that, we actually had to find a way to dynamically split the test, because previously, when we were splitting them, we were just going, give the first 50 to this one, the second 50 to this one, etc. So we ended up just populating that global Redis service that Tom was talking about with a big list of test case names, and then based on the amount of resources that we thought would be available, we'd tell the containers, grab this many from the service, from the Redis service, and then run the test, store the results. So this is just a look at that cluster. So there's two colors of tests indicating that 2 teams or more could run their containerized tests at the same time. On the first worker column, there's a Docker registry which is accessible to every node, and then on the last one there's a Redis service which is also accessible to every node. So that stuff isn't being duplicated out, but it is accessible to all the nodes. So all the test case names are sitting in that Redis one, and then every time you start a container to test things, it can pull out a group of tests, run them, and store the results for you in the shared volume.
Okay, so yeah, it's as simple as this for creating a new test service. It's just a matter of creating the service and pointing at a Docker image. Okay, once you specify the number of replicas you want, replicas it just basically means the number of tasks that will run. Docker Swarm manages this for you. So if you specify 10 replicas, it'll ensure there's always 10 replicas there's always 10 containers running across the swarm. Could be in any node. If one node goes down, it'll reschedule the container on another healthy node for you. This gives you a bit of resiliency in your test infrastructure. Whenever we first did this prototype, I'd set up a dozen nodes, but half of them were misconfigured. And I didn't even realize because the tests were still running. Swarm was able to just redirect the test into the containers that ran on the healthy nodes, and the other nodes were just left doing nothing. Okay. And for anybody that uses Jenkins, this might look quite familiar. This is a typical sort of pipeline that we're putting together at the moment. You can see here most of the tasks are very quick. We're just setting up a network for our test to run inside, so it's isolated. We create a Redis service. We populate it with a list of tests. The longest part of the pipeline, you can see, is 3 minutes, 29 seconds. That's the actual test execution time. We just start off small. We have 10 replicas that run the tests. And then if we can find enough resources, we can scale up to 100 containers or 1,000 containers. It's highly scalable. Just if you want to keep throwing more nodes into your cluster, you can keep scaling up. It's worth mentioning that the nodes in the cluster are platform agnostic. We have nodes in the cluster that are running on OpenStack, OpenNebula, AWS. For the Swarm experiment, there's just basically every cloud provider that runs Linux had some sort of Docker engine running on it. Yep. We didn't want to just stand here and put out loads of buzzwords and kind of baffle people. We want to actually give you the code that we used. And this is what it looks like. This is our new test run for the project that James is working on. It's as simple as creating a network, populate a Redis service, and then start your test service. Each test container comes up, looks for tests, runs them, then destroys itself. Next one comes up, grabs more tests. You can see. Oh, sorry. You can see here we have the replicas set to 12. If you have some code that will determine how many resources are available in the cluster, you can just scale that up to whatever's available. If you need to go up to 1,000 containers, you can do that, and Swarm will just handle it perfectly. Okay, so there's loads of built-in stuff in Swarm. A lot of you probably know Kubernetes and Mesos Marvin. Swarm's basically looked at a lot of the key features in those tools and tried to build it into the Docker CLI. Stuff like rolling updates is great. So if build engineering wanted to provide a service to test against, we could do rolling updates so that it always has the latest version, and the tests just use whatever's running. Load balancing, service discovery, it's stuff that you used to have to do manually before Swarm mode was released, and now it's just a one-liner. It's really straightforward to get going. This is all documented on the Docker site. There's a full list of built-in features in Docker Swarm mode. And Swarm basically solved a lot of these problems. We have completely scalable tests. We have only picked the one project at the moment, but we're going to roll this out across other projects that are even more troublesome, where we have like tens of thousands of tests. This was quite a small scale prototype. It was only 1,200 tests, I think. But we reduced the test time from 9 minutes down to 3 minutes just by like having those extra resources in the Swarm cluster.
So like, as I mentioned earlier, you know, the kind of elephant in the room of this is that you are still increasing your resource usage. You are still increasing like the money that you spend, whatever way you calculate that. But like, it's sort of a smarter way, we think, of doing it. Like, you're not just beefing up your one EC2 until it can run everything. You're actually going, okay, we can spend the same money and like kind of spread things out in parallel execution until we have a more scalable solution that doesn't run into wild like RAM issues and stuff like that. And like, you know, the actual amount of time we spent on this was really, really low. Like, I kind of did about an afternoon, if that, and you know, Tom did most of the work, but even he only spent like a week or two, even less.
Yeah, probably even less. Just kind of getting to know what Docker Swarm could do took about a week, but the actual getting the test running, I think it took us a day and a half. So it was really
so it was very limited time spent really. And then we have obviously got all our open source friends, Docker, Ansible, Cluster, and Swarm Visualizer. And like Tom was saying earlier, we've scaled across 3 different platforms: AWS, OpenStack, and OpenNebula. So pretty nice. Oh, sorry.
Okay, so
we are hiring slide.
Yeah, this is kind of like the default slide we always have in. We're always hiring. We're looking for the best engineers, and we also have a lot of internships as well. If anybody's interested in working in the games industry, you'll learn so much in 6 months or a year. It's just crazy the speed at which the technology is moving at the moment. So we have a stand just outside if you want to drop by and get more details.
Yep. There's our contact stuff. We'll have these slides available. Pretty sure they can be available, but there's just if you want to quickly know. We have a meetup, Docker Dublin, which is happening. Next one is 2 Thursdays from now. And there it is.
Yep, so if anybody wants to learn about Docker, come along. We're going to try and match people up one-to-one with a mentor. So you'll sit down and basically do everything from scratch, build a Docker image, run a container. It's just a great way to learn from people who have been using containers for a while. So everybody's welcome to come along. It's going to be on November 17th, I think it's a Thursday, and it's going to be in the Workday offices. So if you want to sign up with that previous link on the meetup, we'd be happy to help you learn about Docker.
Yeah. So we got the 5-minute warning just there, so we have time for questions, which is great.
So you mentioned that you recently switched to the latest Docker that introduced health check. Do you use that instead of your homegrown health checking scripts? How did it go, or are you planning to switch to it?
Yeah, great question. Health check is something that Docker introduced into your container image, and you basically can tell if the container is healthy. We used to use Bash to do this, but once that got released, like the developers overnight just stripped out so much Bash and so much like hacky code and just replaced it with a single one-liner health check. So yeah, we do run that in all our production containers. Yep. Sean.
Hi, over here. You're next. Oh. So you're using Swarm for orchestration and stuff. What informed your decision as opposed to, I don't know, other alternatives like Kubernetes?
Yeah, it's another great question. Yeah, so one of the things that really, well, in Demonware, like we move so fast, it's kind of hard to get developers tied down to a tool or try and get everybody moving at the same time. Trying to get Kubernetes or Mesos Marathon rolled out across Demonware was quite a challenge. We had lots of discussions about this. But whenever developers moved to Docker 1.12, they automatically had Swarm modes on the command line, and they had access to Swarm clusters. So it was literally just because it was so easy to pick up and use. That was the dividing factor. And also, Docker are really putting a lot of resources in the Docker Swarm at the moment. So we're hoping by this time next year it might be production ready, and we might start to look at using it more widely.
Hey Tom, I was pretty much going to ask the question you just sort of half answered, which is
are you planning on taking your production services onto Docker anytime soon? And if you seem to have had an awful lot of success with it as a test framework, so what are you seeing as sort of the barriers between using it as a test bed and using it as a production environment?
The biggest barrier at the moment is trying to find the resources in each development team. They basically need to tweak how their tests are running, and that takes a lot of commitment from the teams themselves. We can provide really quite cool test infrastructure that scales in and out, but if the tests aren't cluster aware, then teams can't use it. Yeah, so what was the first part of your question? Oh, yeah. I don't think we can talk about our current state, but it's I think in the new year, we can announce the stage we've got to with Docker containers. We just can't say at the moment because a few things are up in the air. But like as I say, we have about 3 years experience of Docker. We got in really early, and because we have so much experience across the company now, we think if we do run it heavily in production, that we will be able to just manage it like properly.
We have.
Can you give some idea of the scale of a test? I'm thinking unit test, there's a couple of lines of code to a suite of these. How big a chunk do you put into one of these containers?
Yeah, great question. This depends on the runtime of the test. If the test takes 1 or 2 seconds, then we'd probably cram in a few hundred tests into one container, because it's kind of wasteful to bring it up and bring it down so quickly. But if the test takes a bit longer, we tend to run those in like longer running containers. We mentioned unit tests a lot, but we're actually going to use this for other tests. So for system tests as well inside a Swarm cluster.
And Selenium.
And Selenium tests and replicated tests. So we plan to use this quite heavily, not just for unit tests. But yeah, the ability just to be able to scale out whenever you're in a rush to get something out to the customer is just fantastic. We don't have that at the moment. So
yeah. There is a section in the slide, but it says like in that example, we were scaling about 50 individual test cases to each container. Just that's an example. Yeah.